Okay, good afternoon, ladies and gentlemen. Welcome to the AFA engagement on propulsion. I'm Gregg from the Air Force Research Laboratory. I'm the director of the Aerospace Systems Directorate, and in that directorate, in the portfolio, we have propulsion systems and hypersonics and air vehicles and the rocket lab at Edwards, power and control, autonomy, and I'm forgetting something here, sorry. Coming here from Dayton, and we have an all-star panel here. Going from left to right on my screen, we have John Kusnierek from Rolls-Royce LibertyWorks. We have Darin DiTommaso from GE, and we have Dave Stagney from Pratt Whitney. So with that, I'm going to give our esteemed panelists an opportunity to introduce themselves and their interests in this area. So John, let me turn it over to you first.
Yeah. Thank you, Dr. Gregg. Thank you for inviting me here to represent Rolls-Royce at this important session. I lead LibertyWorks, which is our innovation hub. We are based in Indianapolis and service all elements of the DoD and particularly work in TRL levels that range from TRL 1 through 6. Thank you.
All right. Darin?
Hi, thanks, Dr. Gregg. I'm Darin DiTommaso. I'm Vice President of Engineering in GE Edison Works. And in GE Edison Works, we do all of the technical development, sustainment associated with our existing core products, as well as next generation products, and a suite of technologies that really serve both those aspects of our business. Happy to be here.
All right. Dave?
Great, thanks again, Dr. Gregg, and to the AFA and the Air Force for hosting us. I'm Dave Stagney from Pratt Whitney GATORWORKS. We are also the advanced technology and product development arm of Pratt Whitney's military engines, and also working on everything from a blank sheet of paper to upgrades of the 135 engine. So it's a really exciting time, and I'm excited to have a conversation today.
All right, thank you all. So let me say for the attendees out there to please use the question and answer function at the bottom of the page. Don't raise your hand, or you don't have to wait till the end. Please go ahead and type your questions in as we go along. Thanks. So let me start. Given the impact that COVID has had on the airline industry, all of your companies have had a huge impact in the commercial sector. Can you tell me, I'd like to hear from each of you, can you tell me how does this affect your military related investments? Are we going to have a hole here while you're making sure you can do what you can for the commercial side, or how does that play off into today's environment? John?
Oh, thank you. Yeah, regarding the big picture economic outlook for the propulsion business, the impact of COVID and the pandemic has certainly been very severe. And as you all know, we're actually rapidly closing in on 1 year since the impact really hit commercial aviation. I view this as a little bit of a larger question than the propulsion business alone. It is a question for all of aviation. Aviation is an ecosystem, if you will. So whether building or supporting the engines, pilots, refuelers, MRO operations, supplying parts, et cetera, the impact is big and wide, and I think that's worth considering. Any of the statistical details of this are out in the public domain, and you can easily see the impacts across the aviation industry. For the time being, the propulsion business will certainly survive, and we look forward to the most rapid return to normal that we can achieve, consistent with safety, as do all of our industry colleagues. Particularly important to this outlook, I think, is the defense business. I am really happy to say that our company workforce and suppliers actually adapted rapidly to the COVID pandemic. We were able to maintain delivery in the defense market, support our defense commitments without interruption. And so this demonstrates the resilience. I think it demonstrates the possibility of delivering defense critical items during the pandemic, and honestly, the commitment of our workforce as well. The larger question, I think, would revolve around how long the impacts would continue, what the recovery profile looks like. And so those are the recovery is still before us. I think there's various amounts of positive news out there, but timing certainly is an overall factor.
Thanks. Dave?
Yeah, thanks, Dr. Gregg. It's been a really tough year for us, you know, and I think that's from a personal perspective as well as a professional and a company perspective. You know, Pratt has a pretty significant commercial business, and you know, we had roughly about a 65% decline in sales in our commercial products and services, and that's affected the whole company. We had to take a number of really serious cost containment measures. You know, we had to defer merit increases. We had a furlough. We had travel restrictions. We had some involuntary separations. You know, restrictions on hiring, capital, discretionary, including, you know, R&D for a number of the key things that we're working on. So that's absolutely affected us. We took some actions to really kind of stabilize our supply base. And we took about $300 million, you know, of material to accelerate and get some cash out to some of our critical suppliers so that they wouldn't fail last year. They were able to invoice early and receive some of that cash. So that was a really key thing. And obviously we had to, you know, really take a lot of actions. There's a large percent of our workforce that still has to come in every single day to go to work. You know, some of us complain about being on Zoom all day, but people, you know, from day one in March had to be in the office to either work on you know, classified programs or to build and deliver and service the products. And so we had to really make sure that our top priority was getting the right, you know, protective equipment there, you know, not just hand sanitizer, you know, deep cleaning facilities, thermal scanners, all those sort of things that we did. We spent about $30 million on making sure that we kept our workforce safe. So it's been a really challenging time, but again, I think, you know, there's the old cliche that you know, necessity is the mother of invention. And I think as John said, you know, we're trying to take this as a chance to really rethink the way we do things. I think that, you know, the budgets and investment in the long term, you know, we absolutely need to have those to maintain the kind of the dominant position that the US has always had in propulsion. And we cannot lose sight of what we need to do to work together to make sure that we continue to maintain that dominance for the future. But given the reality of where the budgets are for the next couple of years, we're going to have to innovate. We're going to have to think differently about what we do, how we do it, what are the processes that we use, how can we question some of the legacy systems and procedures that were all put in place for a reason. But you know, we've got to adapt and learn and be able to deliver even more results with less dollars available to us in the short term to be able to do that.
Thanks, Darin.
Yeah, you know, I'd say the first and foremost thing that we focused on with the pandemic was the safety of our employees. And, you know, as Dave alluded to, and John, you know, we have to work in a constrained environment relative to the classified space. And so we focused a lot on our ability to maintain cleanliness of those spaces, social distancing, all of the things that you need to do to protect the workforce, because that's really the fundamental underlying element that supports the customer. First of all, it's the right thing to do for the employees, but it's fundamental to being able to continue to deliver for the warfighter, whether we're talking about the legacy products or the advanced technology spaces. And so the other focus I would say we had then was making sure that we maintain the talent that we need to maintain to serve the warfighter. And, you know, that's a really important point. The skills that we rely on to develop and sustain these products are, you know, really unique skills. And so, you know, I want to also recognize the Industrial Base Council for their contributions to the industry. You know, over $123 billion of stimulus money, which has really helped us maintain that talent workforce, which once you lose it is very hard to replace. I agree with John. I think there's still uncertainty there in the market and in the commercial market in terms of how it's going to return. There's some new variants of COVID that are appearing. I think there's some additional restrictions, not so much in the U.S., but in other countries. So I think we continue to look at a long-term recovery for the commercial market. And again, for us, I think it means, making sure that we have continue to develop the right talent, support our suppliers, make sure the supply base is there relative to being able to serve the customer.
Thanks. All right, let's take a pivot, make a pivot here and talk about where we see the future's going. So the Air Force has certainly diminished their investment in the exquisite high-end turbine engines and is looking more for engines in the attritable space. 1,000 hours is all I need, and I don't need the reliability for a manned system if I'm going to put it on an unmanned platform. How does industry get their heads around the business case for attritable engines, which the Air Force is going to need a lot of?
I'll jump in, Dr. Gregg. Look, I think it starts with requirements. We really need to have the clarity around the requirements and defining the mission. And then, I think we can design to that. And I think we can design to it in a way that allows us to, have a win-win for the customer in terms of providing that propulsion system and being able to make a business case for us. But that really, in my opinion, is where the discussion has to start. Do we understand what the requirements are? Whether it be performance, range, cost, all those types of things.
Dave?
Yeah, building on what Darin said, it is about understanding what the outcome is that we want to achieve and not overly constraining our teams. If we want real innovation and allow people to think about the problem differently, you can't give them 1,000 requirements to go build, an expendable engine. We did a pilot, when we started GATORWORKS for a new small engine, and I literally gave the team 3 requirements, and that was it. The amount of thrust, the cost target that the Air Force gave us, and the size of the engine, and that was it. And we let the team kind of come up with what they were going to do, and they made really tough trade-offs. And really good decisions to come up with a better solution, than if they had started out with 1,000 line items on a specification. So I think it's about, thinking about how we're going to actually approach the achieving the outcome from a different perspective. The second thing that we talk a lot about, is with digital and with agile. And I think that the small engines are the place where we should be experimenting and trying those ideas out. Not only are the small engine programs, they're less complex, they're faster. We can do more of them. We can see through the entire life cycle of a small engine much more quickly, and we can try out a bunch of these digital tools and agile approaches that are more difficult to do on a large engine where there's so many people, so many dollars, and frankly so much at stake. So that's, I think, an area where these attritable and expendable engines can be a real proving ground for innovation for us across the industry. And I would hope that we could do more than a century series, the Dr. Roper's vision here. I mean, we'd love to have a whole portfolio of different ideas. Let's try out a lot of different ideas in this space and not be afraid to fly a bunch of things that aren't going to work. We're taking calculated risks. You don't have a person on board, and you don't have to put $1 billion into to getting that first engine to test. We've proven you can do that with literally just a couple $1 million, and so we'd like to do a lot more of those. And then you get engineers that really have the chance to learn by doing and to take some risks and fail and incorporate that into the next iteration without being so concerned about the either the dollar impact or the schedule impact of making a small judgment call.
So I've posed to industry, your companies and more in the last month or so, the idea that, you know, it takes 10 years and $1 billion to certify a high performance engine. And if we're ever going to be competitive in the attritable space and to be able to afford mass on target, we're going to have to reduce significantly the time that it takes to certify an engine and the cost by 50%, I think, at least 50% on both. So how do you see using tools like model-based systems engineering, digital twins? How can we change our design work using artificial intelligence or machine learning to shorten the timelines that you've mentioned there, Dave? We have to drive down our timeframes and our costs to be competitive. So, John, let me throw that one to you.
Yeah, so I think there's really no going back. There's no going back to obviously paper drawings, and we've continued on I think a significant digital engineering journey across industry. The specific improvements do depend, though, on the application. And so, as Dave had mentioned, attritable is a very rich space to experiment in that area. It also depends on whether it's an all-new engine or a derivative engine. But what we have found is you can reach those levels of reductions, but we certainly have to keep several things in mind. First of all, is the specific tools are really only as important as they are good. So that means things like their utility, their efficiency, accuracy, ability to support collaboration. The second is that you really have to couple digital engineering with manufacturing and material science. When you couple those two together, you've really taken a dramatic step forward. And then finally, no matter what the application, the certification requirements will ultimately drive the development and fielding schedule. So I think those are some key considerations. Dr. Gregg, I do want to go back just a little bit to the attritable. How does that business case work? And I think we have traditionally thought of engine and large-scale development in terms of phases. So there's a development phase, there is a testing phase, there's a production phase, and a sustainment phase. And so in attritable, the sustainment phase is probably going away. What does that mean from a business standpoint is that if we were to be doing more or less continuous development, continuous production, and those can be stepped and phased, but if that is the path forward, there is an economic path forward in that direction.
Thanks. Darin or Dave, you want to comment on my?
Sure. Yeah, I think what we're talking about here is tremendous opportunity for the customer, and because of that, we've got to dig deep. When I think about digital engineering, I think about it in several aspects. First of all, just fundamental model-based engineering in terms of how we work within the design community, how we communicate with the supply chain, sharing models back and forth. And there's time to be taken out of the process and cost to be taken out of the process with that. But then you talk about interfacing with weapon system contractors and being able to exchange models in a way that allow more simulation and really taking time out of the detailed design, because we can understand what the impact is at the airframe level much quicker, much faster, without going through multiple iterations of detailed design and being able to make those exchanges quickly. And fortunately, in the digital community, we've had a lot of developments over the past 5 to 10 years around systems that allow us to do that. Platforms, microservices, data science, the ability to manage large amounts of data. I think some of the things that we need to address as an industry to facilitate that It's things like being able to have our supply chain really engage and ingest these models, because you have a lot of different capabilities throughout the supply chain. I think the other thing is we need to be able to manage security. We have to maintain as a #1 goal the ability to protect the security of the data and the analysis and the things we're exchanging. So I think, we work those two angles. I also agree with what Dave and John are saying. I think this attritable space is a great place to try this out and bring in additive as a manufacturing technology. You bring in digital and additive together, I think it's a game changer for the industry.
Dave, thoughts?
Yeah, no, I agree with everything that you guys said, and there's so many good things that we can talk about here. I think that I agree with your goal, Dr. Gregg. We've got to cut the cost and lead time in half, or more. And there's a few kind of major things that drive those that we found that you can use the digital and additive technologies to approach solving those problems. And it's really more about connecting our models together in the first piece, and then changing the way that we actually work. And we touched on a couple of these things. It's not just the systems engineering models, it's how we architect the whole aircraft with the WSC, how the engine and the power and the propulsion and the thermal management all fit together and provide some really innovative new architectures that we can try out digitally very, very quickly, and look for these kind of unintuitive system solutions that we couldn't come up with just by, again, taking an engine specification and flowing that down to an engine supplier and say, build me the best, cheapest engine that's going to meet this stack of paper, stack of requirements. So we can use those digital tools to collaborate and do that differently. As John mentioned, the other major driver of lead time and cost in a development program, we found is really fabricating the hardware for the first engine to test and doing all the instrumentation that goes on to that. We've got a program right now, almost 4 years lead time for some of the critical components. You can't operate at the speed of relevance that we all want to if that's how long it takes. We got to fundamentally rethink the process of how we get the development parts designed and ordered. It can't be this serial process where we have to go through and complete all the design reviews and then go and source the parts and give competitive bids and then go order the raw material. We've got to do real-time collaboration with our key suppliers and what we call kind of progressive release. Actually concurrently designing for the manufacturing process so that we get the yield and we get the best tolerances for the tool package that the supplier has. And then, having small little iterative contracts to go and do just the rough machining and then do some finish machining and move things through. We don't know how the design or where parts are going to evolve as we go through. And so trying to understand and think that we can, quote that and predict that and then hold someone to that schedule for 4 years and then spend all of our time statusing a schedule versus spending our time actually solving the problems and coming up with the best design together with our suppliers and our and the airframers. That's where I think a lot of this digital and additive technology is really going to take us.
So when you guys are good, you're anticipating a lot of my questions here. So when we think about where we need to go in the future to design quickly some of these some of these missions that we want, we absolutely have to design the propulsion system and the airframe and the power and thermal. That's got to be done together, as you mentioned. And one of the ways to do it is to be able to transmit models back and forth. Is there a role for the government to help define what that architecture is, or is that something, the architecture to be able to, what's the model made of? How do you transmit it? Those sorts of things. Is there a role for the government to play, or is that something that industry should lead?
Yeah, I think so, Dr. Gregg. I think some of the basic areas like security protocols, I think there definitely is a role for government. The volume of data as Darin mentioned, can be quite large. And I do want to bring up the point that that we're talking about a large volume of data that must be kept for a long period of time. And so accessibility down the road is important. I think one of the key areas to address is actually what I'm beginning to call the stakeholder tempo. So we've talked about in previous sessions the authoritative source of truth, but candidly, the design is a living thing and it will continue to evolve. In legacy systems, it's quite discrete and cordoned off. There's a PDR that gets approved. There's a CDR that gets approved. But so digital engineering has the prospect of moving forward very quickly, and having the process, the approval mechanisms for stakeholders. Let's say in the design team, in the airframe team, within the companies, within the government, within the operators, having those stakeholders tied together at the right tempo, I think is probably one of those challenges that we're going to have to grapple with. I think it was Dave said, learn by doing, and I believe that is absolutely the case.
So can you, I'll give you a free shot here. Where do you think the government is hindering industry in being able to accelerate this pace of change with the whole digital space? What could we be doing better? So I'm going to do a slight change of tack there. That the thing that probably should be avoided is over constraining. So digital engineering provides through MBSE and other areas the opportunity to really optimize in ways that we probably haven't thought of before. Therefore, it's awesome, but it's possible for the government to over constrain by architecture, by requirements, by other things, such that we end up, frankly, with a legacy solution produced by digital engineering, and that's what we would want to avoid. Thank you, sir.
Yeah, Dr. Gregg, I'll be a little provocative here. I think that the capabilities that we're all talking about with digital engineering, we then really need to marry that up with a change in mindset about program timelines and prototyping. And so, can we move more quickly to a product design when we lay a program out, as opposed to a complex prototype demonstrator? So I think as we look at these products that we want to get to at the end, and the capability that we want to bring to the customer, I think if we could all commit ourselves to that timeline and think a little bit differently about how we traditionally develop these engines through a series of technology programs and demonstrators, and say to ourselves, well, does the capability that digital engineering is bringing allow us to shorten that cycle and get to the product design faster? And so if that's the case, then we have to recognize that relative to coming together from the government's perspectives as far as what is the timeline, what are the required demonstrators and technology demonstrators. And look, if we can do it faster, let's do it faster.
Yeah, no, Darin, I mean, yeah, it's exactly what I was thinking. You know, we're all familiar with you know, proposing programs that progress the technology, you know, TRL, you know, we're going to do a rig, we're going to move it from TRL3 to TRL4, right? We need some programs that, frankly, you know, are increasing the DRL, right? We need specific programs that are going to take this digital technology and put it into a real world practice and advance it to the next level of readiness. You know, how do we get the investment to actually go do that when we know it's not going to quite work, and we don't want to take a risk on a real program that has you know, a true, you know, capability need. The warfighter needs to get this capability out to them. We should not force ourselves to use those as the where we're experimenting. We should have other programs that we can all work together to move this technology forward, so it's ready when we need to move the actual EMD programs through. Where are we taking our risk? We can't take our risk during the actual program. We need to be able to be prepared for that ahead of time.
So stay tuned. I hope you guys are pulling together all your good ideas, because I'm leaning on Dr. Chuck Cross. He's probably listening in to help me figure out how we pull these DRLs. I like that term. We can figure out how to do that and try some experimentation where we have low threat. If we fail, we'll learn quickly, but then we'll take the next step. Okay, I'm gonna take a few questions here from the crowd. We've got expendable engines. Is there an optimal size? Probably depends on the mission.
Yeah, I would say there's an optimal size depending on the mission, but I think the discussion gets a little more interesting when you start to talk about the attritable space, when basically the physics of returning a vehicle start to drive vehicle size and hence engine size, and further than the service life requirements.
Yeah, go ahead, Darin.
I was just to say, I'd agree with John. It does come back fundamentally to the mission. There is an optimum size. It's an optimum size relative to the mission, relative to the required life, relative to the required cost. And so, once we understand that, there's always an optimum solution. It's a challenge, to balance between those, those key requirements, but we can always get there.
Yeah, I think it's about, we talked a little bit earlier about, the requirements that you're going to have, right? If you're going to have something like a loyal wingman that's going to need to fly alongside a fourth or fifth or sixth gen fighter, it's going to have to pretty much do the same type of mission as the main engine on the fighter. There's not a lot that you can do differently there. On the other hand, if you're going to do things that are smaller in swarms or with different types of technologies, I think that's where we can make things a lot smaller and frankly mass produce things, and really drive down the cost using different types of materials. We got to take a risk on different types of things. Yeah, we had a small program. We were going to do an additive version of one of our small engines, and I joked the team originally had several $1 million that we were going to do all the material characterization for the additive part of this, and it was going to cost multiple times the amount of the cost of the engine itself. And so I said, well, let's just print it and run it. We can afford to take a little bit of a risk here because it's safe. No one's going to get hurt in the test, and we can try these things out. And again, I think that's where these attritable systems, we have to think about the types of materials and design systems that we use to really open up that space for us.
So for the audience, how the Air Force is trying to frame this is there's a continuum from a truly expendable, it's probably going to be one mission. And so you want to scale it for maybe 50 hours max. And, it's probably has to have limited performance and limited thrust. You can imagine what you might use it for to clear the way for something else. And then you can have something on the scale from truly expendable all the way up to exquisite, depending on what mission. And somewhere in that middle, in the attritable space, where you don't want to sacrifice a manned platform, but you're willing to sacrifice the attritables, that's where you're probably in the 1,000-hour case. So the choices for design and manufacture production of a 50-hour engine are different from a 1,000-hour engine, or different from a 10,000-hour engine. So that's where I think our panelists are saying, well, it depends what you want to do with it and how long you want to do it. That really drives the optimization.
Right.
Okay. we have another question, and we've touched on it already. Is 3D printing viable for engine components, additive manufacturing? I think, Darin, you talked about that already, but where do you see the role for additive manufacturing in engine components?
I'll kick it off. I think to answer the first part of the question, yes, it's viable. We have 90,000 parts out flying today commercially that are additive, and in the military as well. And I think the challenges and the appropriate place for additive is not simple parts, like brackets. It's really the more complex part that require multiple fabrication steps. Those fabrication steps typically add weight to the part, and they're also an opportunity for quality problems down the line from a supply chain perspective. So, I think targeting additive around those types of parts that drive weight are comprised of complex fabrications to get to the final product are really prime candidates for additive. And the other thing I would say too is additive really allows you to do design innovation without some of the constraints that you typically have with traditional manufacturing methods. The ability to grow a part additively can allow you to design a part more aerodynamically than you could have in the past, as an example. And so it opens up the design space, and it's really important for the design engineer to be well connected with manufacturing traditionally, but even more so now as we bring concepts like 3D printing in. It really has to be a continuum of talent between engineering and supply chain.
Thanks.
Yeah, one of the other key things we talked about lead time earlier. If you look at some of the major lead time drivers, which really hurt us in terms of getting the right spare parts out into the field. Doing development programs is in castings. We're going to take an engine later this year, and I banned all the castings on it. You can't have 2-year lead time and hundreds of thousands of dollars in tooling every single time you want to do either a prototype or a small design change. Well, we need to completely eliminate that bottleneck, and I think we're finding suppliers that we can get the same cast properties even better with additive.
Yeah, I think there's been a lot of work put into ALM for the reasons that Dave and Darin just discussed. The opening of the design space, I think there's still even more room to explore that. We can now make design parts and obviously make parts that were probably impractical or impossible to make before. And that has really helped in certain design space areas. So completely concur with Dave and Darin that ALM is probably here to stay.
Okay, thanks. So we have a question here related to digital engineering and reduced design, validation, iterate cycle. How are your companies partnering with U.S. academia and other laboratory capabilities to help be your generator of ideas or collaborations?
Well, I'll start. We have just a number of collaborations through what we call a university technology network. We also are involved in the material affordability initiative. Again, across the industry, these are typical tools that are used. I would say there is probably one of the better pipelines with regard to ALM, additive layer manufacturing, from those academia areas and basically I'll call them think houses that exist across the United States. We also are involved in MXD on the manufacturing side to have that continuum all the way from material science to manufacturing.
Yeah, I'd say for us, we have a university strategic alliance program that aligns with university capabilities in a number of technology areas. Digital is one of them. We also have a digital business, and there's the same type of connection into that digital business into the academic community with regards to data science, connectivity, and processing power and speed, which are really the fundamentals of the things that we're going to have to develop as a business to be able to execute the vision that we're all talking about.
Yeah, but we're I think the main area we're applying our digital right now. Another area that we haven't talked about really is on the sustainment side, and how we actually look at what the commercial side of our business is doing, and taking some of the digital tools that they've developed to really rethink the way that we manage the spare parts, using machine learning to get the right parts in the right place and the right time. Working with a lot of small businesses to help us, move things around and manage solve different problems in the sustainment business has been a really exciting opportunity for us.
So, slightly different direction. Commercial airliners have really gotten big into condition-based maintenance. The Air Force has kind of dabbled in it. How do you see pushing into condition-based maintenance helping the Air Force current sustainment challenges? How can the Air Force collaborate better with you and the airlines to learn how you're doing it and doing it very well?
Yeah, well,
go ahead, Darin.
Well, yeah, I think it starts with a focus on that and a commitment relative to developing those types of capabilities. The ability to develop analytics that better predict hardware condition has been proven in the commercial side. The ability to automate inspections or interpret things like borescope inspections with an artificial intelligence approach versus relying on human eyes and human judgment. Those things are underway in the commercial side. I think it comes back to a commitment that this is something that we want to go do, starting with the customer, and that we need to fund some of these technologies to adapt them to the military side of the house. I think it's very achievable and doable. We got to have the right business models around it and the right seed funding to mature the technologies in this space.
Yeah, I agree. We've got to do some experiments. We got to, like you said, Darin. I mean, these models are proven. We know how to do it. We've got to find the right programs where we can jointly work together. We all have the same outcome, right? We want the fleet to be flying, and we want to provide the absolute level of readiness and safety and dependability that the warfighters need. That's our collective goal together. We've got to find ways to get past contracts and some of the other barriers that we have that maybe make it more difficult for us to try out some of these different ways of working together. We all want the same goal. There's no doubt about that.
Yeah, I think Dr. Gregg, from what I'm seeing, the interest at the depot level in machine learning is an avenue to get to condition-based maintenance or CBM plus and so forth. So we've actually seen a pretty good uptick in the interest in that over the last few years. I think it is definitely achievable, and as has been discussed, probably very beneficial to the Air Force meeting sustainment challenges.
Thank you. So here's another question from the audience. What role do you see for electric engines and or hybrid engines? And when do you think we'll be seeing them more in the DoD portfolio? And when do you see them becoming more ubiquitous in commercial space?
Well, I'll
John?
start off. Yes, I think what everyone is seeing is starting off at these smaller, shorter range size classes, whether that is carrying a small box or carrying one or two individuals. That's how it's starting off. A lot of those systems are all electric, meaning battery. From the studies that we've participated in, there is an evolution that can occur to larger systems. I think from a military perspective, it comes back to mission performance. And so for a given mission, some of these missions may not exactly exist. So is there a mission to move one military member 50 miles quietly with all electric propulsion, for example? Or is it more in the troop transport kind of realm? Certainly, we are seeing advantages to electric and hybrid electric, and the technology is maturing. There's a tremendous amount of interest on the civil side in those propulsion solutions, and I'm sure they will make it into the military inventory.
Dave?
Yeah, this is a really exciting area for us, and we're working really closely with our commercial side because, as John said, there's a lot of demand out there from a sustainability perspective, right? And global warming and climate change. We absolutely understand that these different technologies, we have to become more fuel efficient and provide longer range. And in the military, you have some different types of missions that you also want to achieve, but the fundamental building blocks are all there. We just need to go fly some of these vehicles. You need a program that's going to be disruptive and it's going to put something out there. And that's what we're working on with a couple of partners right now is how we can actually go fly something.
Yeah, I'd agree with Dave and John. There's sustainability is such a significant issue on the commercial side, and it's really driving a lot of innovation. And hybrid electric is an area where it's driving innovation. I think we could be seeing those types of systems targeted at the next generation narrow body type of aircraft, and then being able to be leveraged over to the military side. I think one opportunity area is UAVs. The right size vehicle. I think from a technology standpoint, you have to really try to design for the difficult case, right? Which is high voltage systems, megawatt class systems operating, at altitude where you have challenges around coronal discharge and installation and things like that. So solving that problem really then allows you to take that technology and bring it down, whether it be in voltage, whether it be in wattage, and whether it be at different parts of the flight envelope. So I think I agree with Dave. I think it's a very exciting area and a lot of opportunity, certainly on the commercial side, but then leveraging over to the military.
So you just mentioned it, touched on a little bit there. And as we go forward, there is always an insatiable appetite for more power for applications, whether it's commercial and military. So what do you see are some of the challenges in the power and thermal space to help take advantage of some of this power that are generated?
I think, from a power and thermal efficiency, so, power generation, obviously, in the right form factor is really important. Weight, obviously, in an air vehicle is critical. So, power density, the ability to generate megawatt class power in the right form factor and weight is critical in terms of the viability of that concept. Extending the discussion then into the thermal arena, I'll go back to a discussion around additive. additive really gives us the ability to design heat exchangers in a way we've never been able to design it in the past. And so with that kind of a technology, I think we can offer to the platform more thermal efficiency than we've ever been able to offer before.
Yeah, and I think the way to do that, again, I mentioned this earlier, is kind of, rethinking the whole architecture of the system, right? Again, it's not just about taking an existing engine or an existing aircraft and saying, okay, how can we squeeze out an extra megawatt? We're actually working on some prototypes of that right now, and it can be done, and we've shown that it can be done. But there's more efficient ways to do it, and it's, again, you've got to think about how you actually design the whole system if that's what you want, and you want to continue to, you're going to continue to need more power as the aircraft grows and the electronics and these other systems provide more capability to the platform. We've got to think in a modular type of a strategy going forward so that we can add that capability in and not have to kind of redesign the whole aircraft every time you need more power.
Yeah, and just to build on that, I think the point Dave is making, this then leads to a discussion of the overall, aircraft system. It's not the engine system in and of itself. Now it's the aircraft system, which is, a somewhat of a different way of thinking. We've always talked about optimizing the aircraft, from a range perspective as an example. But now you talk about optimizing the entire platform from a power and thermal perspective. And I think you really need to be able, and this comes back to the digital engineering discussion in terms of being able to have the efficient interfaces with the WSCs to be able to understand as we iterate the design and as they iterate the platform, what is the overall optimum architecture.
Right. Yeah, because there's so many system dynamics that are going on there, right? You can't just pull more bleed off the engine to extract more power. Yes, physically you can do it, but the consequences in terms of the sustainment cost, the life cycle cost of the engine, burning up the hot section faster and changing the whole sustainment strategy and spare part strategy. There's a lot of unintended consequences that we all have to work together to find out what the optimum solution is. We can't do that individually. And again, that's where, going back to the digital side, there are probably solutions that we're not even thinking about. If we can set up the right models and get our engineers to kind of cross some organizational boundaries, we can come up with something that's a lot better than any one of us could individually.
John, do you want to chime in?
Yeah, I would just say at the larger power levels, in other words, larger vehicle size classes, hybrid electric rapidly becomes a thermal management problem. So there's no alternative really other than to have a fairly integrated system. However, as I think Darin pointed out, to the platform level trades become very interesting. This quickly leads into discussions about distributed propulsion, which are very, very much a system level optimization as opposed to a propulsion level optimization.
Thanks. All right, last comment here from the audience. The unintended consequence of vanguards has been reduction of traditional investment in propulsion 6.1 through 6.3 at AFRL. This action has resulted in dramatic reductions in technology advancement in an industry that has historically led the world. So I would say that's not an unintended consequence of vanguards. It is because the roll-off of large investment in turbine engines preceded vanguards. But it is true that the Air Force has reduced significantly investment in that area. Maybe as a wrap up, if you all could comment about what you see the future is with continued reduced investment by the Air Force in this higher end space.
Well, I think so Vanguard, as General Pringle mentioned the other day, if there is 2 or 3 Vanguards, that's where we perhaps sit today. But as the number of Vanguards would increase, and they would potentially need propulsion solutions of an advanced nature, then that actually creates a kind of a positive ecosystem of a system solution with propulsion technology in it. I would say that that this has to be watched carefully. Propulsion has been a centerpiece of our national security strategy for a long time, so certainly attention is warranted.
Thanks, John. Dave?
Yeah, I can say, I mean, there certainly is a lot of investment. You look at programs like AETP and other things. I mean, we're coming up with some unbelievable innovations there. And the Air Force is obviously driving that. So, it's just a matter of, how we think about, the change between some of the traditional technology development and some of the short-term, realities of the budget that we talked about earlier. I do think that there's a fear that a lot of us have that, we're kind of sub-optimizing for right now, and we're going to, pay for that in 10 years because we don't have a full and robust pipeline of next generation technologies. But certainly can understand, we need to kind of rethink the way that we develop our technologies. And if it can be through these, multiple iterative programs where we are constantly upgrading and constantly, introducing new technologies into actual programs that provide value to the warfighter in the short term, that's kind of a win-win that we would like to see. Just one last comment, and we're going to run out of time. One thing we didn't get to talk about in this, we talk about innovation and some of the things is diversity. And one of the things that we're really, seeing is, you've got to have a really diverse team. If we're going to solve some of the problems that these budget problems and investment and technology problems, we've got to have a really diverse set of talents. That means people from, all different backgrounds and all different, perspectives outside the industry coming in and within our teams. And we got to really listen to those people and give them a chance. They're going to come up with ideas and they're going to propose things differently than we would. And I think as leaders, we've got to be able to really, let people try out ideas, even if it's not the way that we would have done it, or the way that we've historically done it. We can't put the burden back on them to do a bunch of business cases and PowerPoints, to justify. We've got to let people listen to people with different ideas and let them try things out.
All right, Darin, your comrades left you 3 minutes.
Yeah. So back to your question around technology investment. Look, it comes back to what are we trying to achieve with the weapon system? What are the goals? Whether it be range, thrust, acceleration, durability, and I think it's a watch item that the propulsion technology can enable significant step changes in those critical requirements that provides capability to the warfighter. So it really starts with that discussion. I think, as Dave said, it's important to be able to have a suite of technologies that you can bring to the table, assuming that those step changes in those types of goals are what we're chasing. I think that a few other comments I would make is the more efficient we can be about the contracting process, I think only drives efficiency into the timeline that we talked about earlier. When we talk about digital engineering and all the very exciting things we discussed that take time out of the system, that's great, but we also have to put efficiency into the contracting process. And I think really a commitment that says, if we're going to go, we're going to go. If we're going to develop a platform, we're going to develop a platform. The funding's going to be there, and we can all get on board with that shorter timeline and drive to that conclusion. I think Dave makes a great point about diversity, and it's a critical focus in our business, and I'm sure John as well. And absolutely right. The fact that different perspectives bring better product and better designs in the long run. We've seen it, and it's a significant focus. And I think it's something for our industry to really pay a lot of attention to, starting with STEM programs back in the elementary grades through high school that really create that pipeline of talent and encourage people to go into the programs, technical programs at the university level that the entire industry benefits from in the long run.
With that, we are out of time. So let me wrap it up by thanking our panel. This was very good, informative. I learned some things. Appreciate the dialogue. This is a great time to be in the propulsion business because there's many exciting things going on right now. So with that, I also thank all the attendees who participated and wrote in some questions. With that, we are adjourned. Thank you all.
Thank you. It's a pleasure.
Thank you. It's a pleasure.